All right, let's do a couple more example of truth tables, and then you can practice on your homework, but I did want to give you some more that's not just conditional, converse, inverse, contrapositive. So we want to do a truth table for this, okay? So we always start the same way. We have a P column and a Q column. And we always start the P column true, true, false, false, true, false, true, false. So P and Q, there we go. All right, now I want to look at here and see, do we need a not P or a not Q? Okay, here's a not here. We do need a not Q. We don't need a not P because it's just P. We do need a not Q. So let's make a not Q column. Okay, so if Q, remember we're going to do the opposite of what Q does. So if Q is true, false, then not Q is false, true, true. Okay, now notice this statement here. It doesn't have just a regular Q in it, it has a not Q. So this is a me thing, you don't have to do it, but I'm going to mark through here because I'm done with it. If I don't mark through there, then my scatterbrain is going to use it or try to use it. All right, so now we can do the P implies not Q. Okay, so we have P as our hypothesis. This is our hypothesis. And my not Q is my conclusion. So remember, the only time we have a false statement is when my P or my hypothesis is true. So my hypothesis is true here and here. And when my conclusion is false. So my conclusion is false here and here. So both of those have to happen, which is right here in this top one. So this one's false. The rest are true. All right, last example. All right, now we want not P implies Q. Okay, now this is logic, not algebra. And the reason I say that is because we can't distribute. Some of you are going to want to treat this like a negative sign. We can't do that. So what I'm saying is not P implies Q is not the same as not P implies not Q. Okay, don't do it. Okay, it's not the same. This is logic, not algebra. All right, so we're going to start our table. We always start with a P column and a Q column. You should know by now how to start it. True, true, false, false, true, false, true, false. Okay, now I'm going to look at the inside out. So I'm still going to want to do what's in parentheses first. Okay, so I'm still just going to go P implies Q. Okay, P is my hypothesis, Q is my conclusion. The only time this statement is false is when I have a true hypothesis and a false conclusion. Okay, that would be right here. So this statement is false, true, true. Okay, now is when this not comes in. Okay, so now it's not parentheses, P implies Q. Well, guys, if P implies Q is true, false, true, true, what do you think not P imply Q's means? It just means to do the opposite. You know how we go from P to not P? Well, P imply Q to not P implies Q is just the opposite. So if this is true, false, true, true, this has to be false, true, false, false, and we are done.